Sarcosuchus was one of the largest relatives of crocodilians during the reign of the dinosaurs. Estimates of its size range from 9 to 12 meters long, which has inspired nicknames such as the Super Croc and the Emperor of Crocodiles. This exceptional size allowed for Sarcosuchus to become one of the top predators in a world otherwise dominated by dinosaurs. Despite its nickname, the Super Croc was not a crocodile, and technically not even a crocodilian. Crocodilia is a crown clade, meaning it only contains all living crocodilians, their last common ancestor, and the descendants of that ancestor. However, Sarcosuchus was closely related to true crocodilians. It and the other crocodilomorphs who already had most of the traits associated with crocodilians are united with them in the more inclusive clade Neosuchia. Adding to the confusion, Sarcosuchus had been classified as a crocodilian when it was first found, since Crocodilia did not receive its modern and fairly restrictive crown-based definition until later. Sarcosuchus itself is a genus with two known species. The most famous, the type species Sarcosuchus imperator, is found throughout North Africa. Its fossils date to 110 million years ago and were first excavated in 1947 by paleontologist Dr. Albert Félix de la Parent. Sarcosuchus imperator was named and described in 1966 by Dr. France de la Parent de Bois, the niece of Albert Félix, and Dr. Philippe Taquet. Its scientific name means emperor flesh crocodile on account of its size and predatory habits. More Sarcosuchus imperator fossils have been found since then, the most complete of which was put on display in the French National Museum of Natural History in 1999. However, what made Sarcosuchus famous was the publications done in the aftermath of a series of paleontological expeditions led by Dr. Paul Sereno between 1995 and 2000, which found even more fossils of this titanic Neosuchian and the creatures it coexisted with. Working together with National Geographic, Dr. Sereno helped make Sarcosuchus one of the most famous extinct relatives of crocodilians, and it was he who coined the nickname Super Croc. The other named species of Sarcosuchus is Sarcosuchus harti, which lived in what is now Brazil 125 million years ago. While less well known than its African cousin, Sarcosuchus harti did appear in BBC's Chased by Dinosaurs. Its species name is in honor of Charles Hart, the paleontologist who found the fossils. Sarcosuchus harti had actually been identified as a distinct species in 1869, nearly a century before Sarcosuchus imperator. But it had been shuffled between other pre-existing Neosuchian genera, first Crocodilus, then Goniopholis, before being recognized as a second species of Sarcosuchus in 1977. Fossils of Sarcosuchus harti are fairly limited, mostly restricted to teeth and parts of the jaws. Even some of these sparse remains were unfortunately lost in a catastrophic fire at the National Museum of Brazil in 2018. Due to its fragmentary nature, the size of Sarcosuchus harti has not yet been calculated, but what few fossils have been found are smaller than those of Sarcosuchus imperator. Although it was gigantic, there is disagreement over just how large Sarcosuchus imperator itself was. In 2001, a paper by Dr. Paul Sereno and his team estimated that the largest Sarcosuchus imperator specimen came from an individual with a length between 11 to 12 meters, the length of a bus, and a weight of 8 metric tons, comparable to that of Tyrannosaurus rex. Such a size would have made the Super Croc a contender for the title of largest Neosuchian. More recent papers place the length of the largest specimen of this giant crocodilomorph at around 9 meters, with an upper estimate of 9.5 meters. The difference between the older and newer estimates regarding the Super Croc's weight are even more dramatic, with a range between only 3.5 to 4.3 tons. This is still huge, but not on par with the biggest theropod dinosaurs. That said, in science, the more recent estimate is not always more accurate. The newer, lower estimates were purely determined from calculations of crocodilian size based on head width and femoral midshaft circumference. Dr. Sereno's team's larger 12-meter estimate was instead based on head length. While often dismissed as outdated, they had also been working extensively with the known Sarcosuchus imperator material, which accounts for pretty much the entire length of the animal except for the tail. They also helped National Geographic create their detailed reconstructions of the Super Croc, so they would have been in a better position to realize if their 12-meter estimate didn't match the actual fossils. Regardless, the largest Sarcosuchus skull is 1.6 meters long. Its actual killing power was the same regardless of the size of the rest of its body. Sarcosuchus imperator may not have been a record breaker, but even the lowest estimate of its size still dwarfs even the most exceptional living crocodilians, and places it among the top 3 largest macropredatory Neosuchians of all time. Perhaps the largest was the North American alligatoroid Dinosuchus riograndensis, the terror croc. It was able to grow between at least 10 to 11 meters long, perhaps even 13, and weighed between 4 to 7 tons. The other was Purosaurus brasiliensis, a giant caiman from South America. Based on comparisons to modern caimans, it is estimated to have had a length between 7.5 to 10 meters and a weight between 2 to 6 metric tons, although older papers propose a greater body size. Dinosuchus primarily lived along the coast and nearby brackish waters, while Sarcosuchus and Purosaurus both inhabited freshwater rivers and wetlands. There were some other megacrocs like Euthecodon who exceed the lower estimates of Sarcosuchus' size. However, they did not exceed its ferocity, as these species had the long, narrow snouts of specialized piscivores, fish eaters. Although not restricted to aquatic prey, their jaws were not strong enough to hunt prey anywhere close to the size of what the supercroc was capable of taking down. Its bite force is estimated to have been 18,000 pounds per square inch, or 80,000 newtons. This is 50% greater than the power of Tyrannosaurus's bite, and about 5 times greater than the bite force of the saltwater crocodile. It was still lower than that of Dinosuchus, who had a more robust skull than Sarcosuchus. Compared to it and modern crocodilians who hunt large prey, the supercroc's snout was disproportionately long, 75% of the skull's length. This is called the Longirostine condition, and such snouts are typical of piscivores such as Tomistoma, the false gharial. Sarcosuchus' snout was considerably wider than those of other long-snouted Neosuchians, which allowed it to hunt more dangerous prey. The only other crocodilomorph with a similarly shaped snout was the closely related Chilawan, making Sarcosuchus fairly easy to tell apart from crocodilians and other Neosuchians. Another characteristic trait of Sarcosuchus is that the anterior end of its snout expands outwards. This is most prominent with the premaxilla, which also forms a massive overbite. The expanded anterior region is also the only part of the supercroc's jaws with interlocking teeth, at least in adults, which could have been used to catch fish. The nasals, which are undivided, take up most of the space created by this expanded premaxilla. They may have supported an even more extreme version of the nasal bosses male gharials have at the end of their snouts, which can be used to increase how far their vocalizations can be heard. Befitting its role as an apex predator, Sarcosuchus' teeth are large and sturdy. Unlike those of all modern crocodilians, they have ridges on each side, which were an adaptation to cut through flesh. They resemble the xiphodont teeth of Komodo dragons, many carnivorous theropod dinosaurs, and a number of terrestrial crocodilomorphs. However, its teeth are referred to as false xiphodont, as they have just a slight curvature, while true xiphodont teeth are both recurved and compressed on the sides. The smooth crenulations on the ridges of the supercroc's teeth are also less sophisticated than the true serrations of xiphodont teeth. Still, its false xiphodont dentition suggests the supercroc may have killed its victims in a different manner than used by today's crocodilians, relying on cutting power to kill large prey items rather than drowning them in the water. In another departure from modern crocodilians, Sarcosuchus had 2 types of teeth. The front teeth were longer and sharper, and were likely used for slicing. The teeth at the back of the skull were shorter, thicker, and blunter. They seem to have been adapted for dealing with hard-shelled prey like turtles, or for crushing the bones of dinosaurs. In contrast to the titan-slaying adults, juvenile Sarcosuchus were even less threatening than equally sized Nile crocodiles. They had the same slender snouts seen in piscivorous crocodilians, suggesting they filled a similar niche. Narrow Longirostine snouts are more hydrodynamic, allowing them to move swiftly through the water to snatch unwary fish. As they aged, Sarcosuchus snouts remained disproportionately long but broadened significantly, allowing them to shift to their more familiar role as apex predators. Differences between the jaws of juvenile and adult Sarcosuchus have even been used to suggest the teeth of young Sarcosuchus could have been interlocking as in other piscivores like the gharial. Modern crocodilians also hunt different types of prey as they grow, which is called ontogenetic niche shift, but the skulls of their juvenile forms don't differ so dramatically from the adults. As terrifying as they were, every one of the megacrocs, which terrorized the dinosaurs of early Cretaceous North Africa, had once been a cute, narrow-snouted fish eater. That is not to say juvenile supercrocs were harmless. While they are best suited to catch fish, longirostrine crocodilians will hunt other prey when it is available. Likewise, fish still make up a major component of the diets of large prey specialists. As a reptile, Sarcosuchus still hatched from eggs, so in spite of its massive size, the emperor of crocodiles started out about the same size as today's crocodilian hatchlings. Analysis of a Sarcosuchus osteoderm, a type of bone which grew within the skin, found it had roughly 40 growth rings, each of which are thought to have been laid during a single year. The bone came from an immature specimen, which was about 80% of the length of a fully grown adult. From this, it was determined that it took between 50 to 60 years for the supercroc to reach its full size. Instead of growing more rapidly, Sarcosuchus became a giant by extending the rapid growth phase seen in crocodilian juveniles. While ectothermic or cold-blooded creatures like Neosuchians have slower growth rates than birds or mammals, this wasn't even the fastest Sarcosuchus could have grown. Despite being as large or larger than the supercroc, Dinosuchus was able to reach adulthood in just 35 years. The largest slender juvenile skull is a meter long, a little over half the length of the adult skull, but longer than that of any modern piscivorous crocodilian. Altogether, this means that the supercroc's slender-snouted fish-eating stage would have lasted for decades. Many crocodilians can live past 70, but on account of how long it took to reach adulthood, the supercroc's lifespan was almost certainly greater. Unlike birds and mammals, which exhibit deterministic growth, most reptiles, including crocodilians, continue to grow throughout their lives, so an elderly Sarcosuchus would have been an impressive sight. However, their growth rate after reaching maturity is much lower than before, which is why senior crocs are nowhere near the size of an adult Sarcosuchus. Sarcosuchus's closest relative was the previously mentioned Chalawan, which is estimated to have grown between 7 to 8 meters long. It lived in late Jurassic Thailand, and given its similar skull, is thought to have filled a similar niche as the supercroc. Sarcosuchus and Chalawan belonged to the Neosuchian subclade Tethysuchia, and are most often placed in the branch Phylletosauridae. Tethysuchians first appeared during the Middle Jurassic and lasted all the way into the first third of the Cenozoic era. The majority of other Tethysuchians were marine predators who hunted along the coasts, but a few, such as Elosuchus, inhabited freshwater environments. Nearly all Tethysuchians were specialized fish eaters with thin, longirostrine snouts, resembling Sarcosuchus's early life stages. This explains how the emperor of crocodiles evolved into the famous dinosaur hunter. As its ancestors grew in size, they were able to hunt bigger and bigger prey in spite of their slender jaws. By shifting further in that direction and developing wider, sturdier skulls in adulthood, competition between the different growth stages was minimized, allowing for a larger population than would otherwise be possible. This same strategy was later employed by the tyrannosaurid theropods. While Tyrannosaurus rex was famously robust, its juvenile form had similar proportions to earlier tyrannosaurids like Gorgosaurus. Entering a specialized slender-snouted stage meant that Sarcosuchus's skull was not as strong as those of other large prey specialists, and a study in 2014 found evidence that the supercroc's skull was too weak to perform the death roll. Death rolling is a behavior exhibited by crocodilians where they bite down on an animal they have taken into the water and then spin to dismember it. This is both a way for crocodilians to kill their victims and is their primary method of tearing carcasses into pieces small enough to swallow. Its supposed inability to death roll has been used as evidence that Sarcosuchus didn't actually hunt large dinosaurs. However, the supercroc's sharp false zyphodont teeth would have given it the ability to feed in the same manner as theropod dinosaurs. The authors of the paper also cautioned that the reliability of their results was limited given how Sarcosuchus was far larger than any modern analog. Perhaps even more importantly, the study was built upon the assumption that the modern longirostrine crocodilians cannot perform the death roll. More recent research has since proven this premise to be false. With the possible exception of Cuvier's dwarf caiman, all extant crocodilians are perfectly capable of death rolling. If a species with a skull as delicate as the gharial can do it, the supercroc almost certainly could have as well. Still, the constraints created by its piscivorous youth are likely why Sarcosuchus had a lower bite force than Dinosuchus. However, Dinosuchus is thought to have fed upon hard-shelled prey more often than Sarcosuchus did, and, as mentioned previously, the bite force of both genera still greatly exceeded that of any dinosaur. Much like its living relatives, the supercroc's back was protected by bony osteoderms. Compared to crocodilians, Sarcosuchus's osteoderms had an older arrangement, more reminiscent of their terrestrial ancestors, with two continuous rows starting at the neck and ending at the middle of the tail. Crocodilians have since added additional rows, extended their armor coverage to other parts of their bodies, and have a discontinuity between the osteoderms of the neck and the back. The supercroc's osteoderms were also proportionately larger than most of the other Neosuchians, as they provided much-needed support for its massive torso when out of the water. The osteoderms on its back were long and rectangular, but became shorter the closer they came to the end of the series, becoming almost square-shaped. Although large dinosaurs were common throughout the world during most of the Jurassic and Cretaceous periods, megacrocs the size of Sarcosuchus, even going by the lowest estimate, were a rarity. It wasn't just the available megafauna that enabled this semi-aquatic predator to grow to such titanic proportions, but the massive wetlands that covered early Cretaceous North Africa and Brazil, as well as the plentiful and often giant fish which inhabited them. One of the largest, the Brazilian coelacanth Mawsonia gigas, grew over 5 meters long. It was these sorts of megafish which enabled the evolution of the gigantic Spinosaurus. Some crocodilomorph fossils from the Kemkem beds, the same locality as Spinosaurus, have been attributed to Sarcosuchus, but they are too fragmentary for this assignment to carry much weight. Unlike its depiction in Chased by Dinosaurs, Sarcosuchus harti was not a contemporary of Argentinosaurus or Giganotosaurus, who lived millions of years later. Indeed, those species were not even contemporaries of each other, although they did coexist with close relatives of comparable size. When Sarcosuchus first evolved, South America and Africa were still separating from each other and had many similarities between their faunas. The best studied site with Sarcosuchus fossils is the Eldraz Formation in Niger. The largest theropod known from the site is Spinosaurus's distant relative, the Spinosaurid Suchomimus. Other local predators include the abelosaurid Cryptops and the Carcharodontosaurid Eocarcharia. While these dinosaurs would have been threats to young Sarcosuchus, an adult supercroc is currently the deadliest predator known from the ecosystem. Still, the coexistence of several large predators required niche partitioning between them. Different calcium isotopes found in Sarcosuchus and other local predators were compared to those of contemporary fish and herbivorous dinosaurs. The analyzed calcium samples came from tooth enamel, which, unlike bone, retained its original composition during and after fossilization due to not being porous. The diet of Sarcosuchus was found to be between that of the Spinosaurids, who primarily consumed fish, and the other theropods, who mostly hunted dinosaurs. While not as specialized as when they were young, their longirostrine jaws would still have given adult Sarcosuchus an edge when hunting aquatic prey. One of the most iconic prey items of the supercroc is the ornithopod Uranosaurus. This dinosaur had a tall neural spine which supported either a sail or, more likely, a hump. Sarcosuchus would have also commonly encountered another ornithopod named Lurdusaurus, who is thought to have been semi-aquatic. One of the more unusual components of Sarcosuchus imperator's diet was the small sauropod Nigersaurus, which had a wide mouth filled with numerous teeth. Larger sauropods would have been a more daunting prospect, especially since Sarcosuchus had a thinner snout than other comparable carnivores. However, it would take only a single bite to the neck from the supercroc to kill them, leaving them uncharacteristically vulnerable when they came to drink. The limiting factor determining what Sarcosuchus could hunt may not have been the size of the animal it could kill, but instead the size of what it could drag back into the water, although its false zyphodont dentition may have allowed it to simply feed on the shore. Sarcosuchus was a truly exceptional animal. It was not only one of the deadliest Neosuchians, but one of the most dangerous prehistoric predators. Besides outclassing today's predatory crocodilians, Sarcosuchus juveniles were able to match the piscivorous species as well, showing just how adaptable crocodilomorphs can be. Although technically not a crocodile, Sarcosuchus is truly deserving of the title of Super Croc.
Thank you for watching, and a thank you to themattalorian for narrating this video. If you enjoyed it, please remember to hit the like button, and subscribe if you'd like to see more. Finally, be sure to have a great day.